Morning. Here is another video for today's assignments. This first one, Factoring Quadratics Intro, is something that you were assigned last week, and so I'm just going to go through this a little bit quickly. We're going to factor as normal. I'm going to put my x squared term in the lower left corner, my constant term in the upper right corner. Multiply these two to get the top of the diamond. This would be negative 42x squared, and then my x term always goes in the bottom of the diamond, negative x. So the two terms that multiply to negative 42x squared and add to negative x would be negative 7x and positive 6x. Since negative 7 times 6 is negative 42, and negative 7 plus 6 is negative 1. Put these back into the generic rectangle and find your length and width. X times x, x squared. X times negative 7 is negative 7x, and then x times 6 is 6x. So this is what we would put as our answer, just our length times our width, or width times length. You can put x minus 7 first. That is okay. Over here, same idea. It's a little confusing that they're giving us the rectangle already. What they're giving us is the area and one of the sides. So when I factor, I should get x minus 5 as one of my sides. I'm just going to factor like normal. See what we get. 30x squared on the top. Negative 11x on the bottom. Usually when I have a positive on the top and a negative on the bottom, my two answers are negatives because a negative plus a negative is a negative, but a negative times a negative is a positive. And in this case, it's going to be negative 6x and negative 5x. So find my length and my width. Okay, here you can see that we do have a length of x minus 5, just like they gave us. So what was the missing width that we had to find? X minus 6. Okay, so this is hopefully review. We're going to need to know how to factor to do these next couple of problems. Yesterday, you did the zero product property. And that was where you were given like two binomials multiplied together and then set equal to 0. For example, x plus 6 times x minus 5 equal to 0. And then to solve for x, you set each piece equal to 0. And then you got two solutions for x just by solving those. And those worked because anytime you have two things multiplying to 0, one of those things has to be equal to 0. Well, this is what we're doing today, except they're not giving us an expression that's already factored. We have to factor it ourselves. So here's what I mean. I'm going to start with this example over here. Okay, first let's factor x squared minus 12x plus 27. So as normal, to your generic rectangle and your diamond. I'm going to go through this a little bit quickly. Okay, so we can rewrite this now that we've factored it as x minus 9 times x minus 3 equals 0. Okay, what we learned yesterday in the zero product property exercise again is that anytime you have something being multiplied to something else and it equals 0, one of those things has to be equal to 0. So either x minus 9 has to be equal to 0, or x minus 3 has to be equal to 0. Okay, so let's solve. X is equal to 9. And X is equal to 3. Why am I getting two solutions? Because if I plug both of these answers back into the original product, it's going to make my expression equal to 0. Here's what I mean. If you take x minus 9 times x minus 3 equal to 0, and you plug a 9 in for x, you're going to get 0 times 6 when you multiply, and that's equal to 0. What happens if you plug in a 3 instead? Still going to get 0, because we're going to get negative 6 times 0. That's equal to 0. Okay, so it works. We have two x values that we've solved for that will make this expression 0. So when you put your answer in, find the smaller x, put that in first. So that would be, in our case, 3. And then put the larger x next, so 9. Okay, that's it. Let's do another example over here. I'm noticing already that this is a perfect square. So I can use one of my shortcuts. Ms. Ramirez, how do you know that? Because 25 is a perfect square. That's 5 squared. Okay. Specifically, we used A and B in our shortcuts. So B equals 25. B squared equals 25. So B equals 5. And then I know I don't have a coefficient in front of x squared, but I can put a 1 because 1x squared is the same as x squared. And so if a squared is 1, then a is 1. Okay, go back to the perfect squares notes that I posted on Google Classroom if you need to see the shortcut again. But what this tells us is that I can rewrite this as 1x plus 5 squared and then equals 0. Okay, if you want to factor that out as normal, you don't have to use the shortcut. Okay, I just want to prove to you that this works. I want to make sure that you understand. So let me just do the shortcut really quick. So you can go with x squared, 25x squared, 10x would go down here. 5x plus 5x is 10x, but 5x times 5x is 25x squared. What do you know? It is x plus 5 times x plus 5. Okay. What's nice about this expression is that since it's the same thing times itself, I only have to set it equal to 0 once. So I only have to set 1x plus 5, or just x plus 5, equal to 0 one time. Okay, then I solve for x. X is equal to negative 5. That is what I'm going to put here. If we want to check, okay, x plus 5 squared equals 0. If you put a negative 5 in here, that is going to give you 0 squared. 0 times 0 is 0. Okay, so this works. You don't have to check your solutions every time, but it's a good habit to have. Okay, and then last but not least, this last assignment is very much the same, except these might be a little bit more challenging because we might have a common factor. So notice that I have some big numbers here. I can already see that 3 goes into all 3 of these numbers. So maybe that's something that I want to factor out first and then factor using my generic rectangle and diamond. So let's factor out a 3 first. If you factor out a 3 from 3x squared, I'm going to be left with just x squared. If you factor out a 3 from minus 33x, you're going to be left with minus 11x. Okay. When I'm factoring this number out, I'm just making sure that these, multiply together to get what I already have. So 3 times 11x is 33x. Plus 3 times what number will give you 54? That's 18. Okay, now let's factor this part out as normal. Draw your generic rectangle and your diamond. X squared down here, 18 up here. X squared times 18 is 18x squared. And then I have negative 11x on the bottom. Okay, what multiplies to 18x squared and adds to negative 11x, that would be negative 9x and negative 2x. So put those back into your generic rectangle, find the length and the width. So now I can finally write my fully factored form as 3. Don't forget your common factor, 3, and then your length times your width. Again, you can put width before length. That is okay. Now, just like we did up here, we're going to set each part equal to 0 and then solve for x. Okay, so set x minus 2 equal to 0. Set x minus 9 equal to 0, and then solve for x. 2 plus 2, x equals 2, plus 9 plus 9, x equals 9. So 2 solutions. Here, the larger one would be 9, because 9 is bigger than 2. Smaller one would be 2. Okay, and then we're done. You can check your answers here. 2 and 9 should work. When you plug those in for x, it should make both the expression equal to 0 both times. Okay, and then let's do this last example. Again, big numbers, but looks like I can factor out a 5. 5 goes into all of these numbers. Factoring out of 5 from 5x squared would give me x squared plus, factoring out of 5 from 70x would be 14x. And then, I have to divide 245 by 5 on my calculator. 49, okay. Okay, notice that. Maybe you already noticed this. They're only asking us for one x value, just like they did over here. This is going to be another perfect squares example. So again, if you look back to the special cases notes, the perfect square example is where I have perfect squares at the ends and I can factor it, okay, as just something times itself, okay? In this case, x plus 7. You can factor this as normal to get this if you don't believe me, or if you want to see the steps worked out, but this is what we're going to get, and I just have to set x plus 7 equal to 0 one time. So let's do that. X plus 7 equals 0. X equals negative 7. That's our answer, negative 7. Okay, so go through this video again, pause, rewind, do whatever you need to do. What we're going to see tomorrow, and I'll explain this in tomorrow's video, is this, what we're doing, factoring and setting equal to 0 and solving for x. We're actually finding the x-intercepts for a problem.
Okay, so more on that later.
Let me know if you have any questions, and have a good rest of your day.